Hi, it's Mrs. Moss here, and in this video we're going to explore all the reasons why we have different seasons on Earth. Now, you may have asked yourself several questions when you experience some of these seasonal changes that we have. Why do we have seasons? Why is it hot for part of the year? Why is it cold at other times of the year? Why do we receive more hours of daylight in summer than we do in winter? And why is it always hot near the equator? Well, we're going to answer that and some more in the next video. So the reasons for the seasons, there are three causes. The Earth's axis is tilted, the Earth revolves around the sun, and the parallelism of Earth's axis. Now, seasons have nothing to do with how far away or how close the Earth is to the sun. So get that out of your head right now. The three reasons we have seasons is because the Earth's axis is tilted, the Earth revolves around the sun, and the parallelism of the Earth's axis. Let's look at each one of those a little more closely. So in this animation, you see the Earth rotating in the left-hand picture, in the right-hand picture, and the Earth revolving around the sun in the left-hand picture. Now, you also notice in this diagram on the right, we have an imaginary line that runs straight through the Earth. This is what we call the axis. And it is imaginary, but because the Earth rotates in a certain way, we know that it rotates around what we call this axis. And this axis, as we took notes on before, is tilted. So let's talk about how it's tilted. Well, it's tilted 23.5 degrees from perpendicular. That's the angle at which the Earth is tilted. That is the number that you are going to hear over and over and over again. So keep it in the back of your mind somewhere. We will be asking you about it in future. So it's tilted 23.5 degrees from perpendicular. And here's another diagram of it. Because of this tilt, we have the seasons. Now, in this diagram, you can tell that the sun is on this side of the Earth because this side of the Earth is lit up. And if you look at where the tilt is, and if you look at where the shadow starts to form, you can see that more of the northern hemisphere appears to be tilted towards the sun. And that is what gives us our summer season in the northern hemisphere. Now in this diagram, we have both pictures of the northern hemisphere tilted towards the sun, as we saw in the other picture. But if you look at the opposite side, we also have the northern hemisphere tilted away from the sun. So in this diagram here, we have winter. And it's all because of this tilt that it allows us to either have summer or winter. We're either tilted towards the sun or we're tilted away from the sun. And here's that diagram again. Now, when the northern hemisphere is tilted towards, we have summer for the north. And when it's tilted away, we have winter in the north. So I did just say that, but we're going to say it again because you have to remember this, and you're going to write it down from this slide. But here's something to think about. In the southern hemisphere, it's actually opposite. And some of you may have known that already. If you're in Australia, then you're going to be approaching summer right now, whereas in our northern hemisphere, we're approaching winter. So the seasons are reversed in the southern hemisphere, and that has to do with, again, the tilt of the Earth. They are tilted away from the Earth when we are tilted towards the Earth, giving them winter when we have summer, and vice versa. It's all about the tilt. I'm skipping through these because we're going to show them when we get into class tomorrow, but I want to get to this next idea, this next cause for the season, the revolution of the Earth around the sun. Now, if the Earth didn't revolve around the sun, we wouldn't have a change of seasons. And you can see as the Earth goes around the sun at different times of the year, we experience our winter or our summer. So the tilt of the Earth and the revolution of the Earth contributes to our changing seasons. If we didn't revolve around the sun, the Earth would always be tilted in the same position. And this diagram of the revolution of the Earth around the sun will show you that. If the Earth is tilted and we just stayed in the same position, then we wouldn't have our change of seasons, right? But because we go around the sun as we're tilted, it gives us our towards the sun and our away from the sun motions, which allow us to then have the seasons winter and summer. So there's also this idea of parallelism of Earth's axis. And if you know that the Earth's axis, as I mentioned before, it's invisible, but it always points in the same direction. And in all seasons, all year long, it points toward the North Star, or we call this Polaris. Okay, so what you see in each of these diagrams as the Earth revolves around the sun, and this is depicted here by this circle, the Earth is tilted in the same 23.5 degrees, and it's always pointing in this same direction. Notice this tilt in each of the diagrams. Now we started up here by spring, we're moving down to summer, but notice this tilt. The axis is still in that same position. Then moving on to autumn, again, it's lined up with Polaris, the North Star, and again in this position. We are tilted away in this position, giving us our winter, but if you notice the axis of the Earth is staying the same. Okay, so it's because of those three things: revolution around the sun, the tilt of the Earth's axis, and the parallelism of Earth's axis, that we have seasons. Here's another depiction of the Earth's tilt and how it's in the same position for each of those demonstrated and each of these diagrams as it goes around the sun. So again, you see the Earth's axis will always be drawn in the same way. Always leaning towards or headed for or leaning towards Polaris. Okay, so that's going to end the reason for the seasons. We're going to continue talking about seasons in the upcoming videos. Have a great day.